just figured that out. Wait, you want to do it? Oh god, I just want you.
Guys, you need to be in your seat. The bell is about to ring. Hi, John. How's the game? I'm not done. My bad. Do you remember what you're saying? Yes. Guys, you have 40 seconds. Hurry.
to go off. Mine's up here. Alright, let's see. Thank you, Nor. Thanks, Elena. Jameson, and Cal. Thank you so much. Alright. Okay, really quick. You will need a calculator for this unit. You need to bring it. There's going to be no exceptions anymore. Okay, you need to bring your calculator, charged, with batteries, whatever it is, it needs to be here. Otherwise, I have to give you an unprepared, and I'm going to start taking participation loans away. Okay, so you need your calculator. No more warnings. Your redemption is due on the 20th. Okay, for the quiz. I graded all your quizzes and or your tests, and I will hand them back either tomorrow or the next day. Okay, so those are all in the grade book. Your average is about an 87 out of 100. Okay, so good job. Okay. Alright, now we're going to look at this student's work. Okay, let me unfreeze. Okay, Justin, this was your work. Can you just explain what your thought process was here?
I thought it was I'm pretty sure it was an exponential function, so I found the rate of change of one group and the rate of change of another and divided it with it.
Right. So you thought exponential. What made you think exponential, Justin?
Because it was linear, then there would be a constant change, like you could multiply a certain number to get all of them.
Okay, perfect explanation. So you found what you're multiplying by or around there to figure out what the function's going to be. Okay? Is there another way I could do this, John?
So what I did like this and edit, plug in all the points, and then I forgot all the buttons I pressed, but like I did this thing where it said exponential, right? And then it gave me like the equation.
Okay, John, you're exactly right. We can use our calculators to support us. Doing an exponential regression is what you're talking about. So I want everyone to take out your calculator. Okay, and I got mine right here too. And here's mine. Okay, calculator looks like this. Okay, before we start, you guys need to go to mode. Okay, you should see something that looks similar to this. Scroll down to where it says Stat Diagnostics. Bless you. Stat Diagnostics. You need to turn this on. Some of you have this off. Turn this on. That's the first step you need to do in your calculator. Okay. Alright, now we're going to do what John said. So John, walk me through what I need to do.
You press stat, and then you press edit.
Okay, so John said push stat on your calculator and then press edit. Okay, you should get something that looks like this. Okay, and I'm just going to clear my values. Okay, John, what was the next thing you did?
For the number of minutes, that's your x value, so you can put that into list one.
Okay, so I'm just going to copy this over, and you should be doing this on your calculator. Okay, you need all the list values right here. Okay, and what about, what's next, John? You said x values here, what else?
And then you put your y values.
Okay, so I'm going to put my y values in L2. Okay, and we're just going to copy all this over. This should take you a second. If you're having trouble, look over with your neighbor and they could possibly help you if you're having trouble. Okay, and then my last value is 1752.8. Okay, John, I have everything in here. What should I do next?
You press stat again, and then you go over to calc.
Okay, so I'm going to push stat, calc,
and then you go down to number 8.
Okay, on yours it might be number 8. On some of yours it's going to be exponential regression, so I had to scroll a little bit down. Why am I not using a linear regression here? What did you say was important, Justin?
If it was a linear, then we can just use like slope form to find it.
Okay, so if it was a linear, we could use slope form. What else do you see on this calculator, Jameson?
Well, just not looking at the table, like it's obviously not linear.
Okay.
Yeah, so Jameson's exactly right. We used the table to figure out that this function was exponential. So instead of using a linear regression, we're going to use an exponential regression. Okay? And now we're back here. So you should hit exponential regression. So you should hit 0. Okay, walk me through what's happening now, Tyler. What should I do? Can you just speak a little bit louder so we can hear you up front? Okay, so this is going to pull from list 1, list 2 for our x and y values. Okay, I'm going to hit enter until I get to calculate. Do you want to calculate an exponential regression? Yes. Okay, and we're going to get this. Why is this helpful now? What do I know? Yeah, Jameson.
Well, we can plug A and B into the equation and get your answer.
Okay, so we have our equation right here. And you're exactly right. We have our A and our B values. Okay, our A and our B values. What about R squared? Anyone know what that means? Okay, I got 4 hands. Ben, what do you think?
It kind of tells you like how accurate the coordinates given to you are. So the closer to one, the more accurate the closer to 0.
So what do you mean by accurate?
Like the line, the exponential function, the line, and like how close it is to those lines.
Yeah, so how close? Okay, so Landon or Max, did you guys want to add? Okay, our R squared term is actually going to be our predictability. So it's our accuracy, like Ben's saying. Okay, so that's going to show us how accurate our regression is going to be. So if we have a 0.99999 exponential regression, is that going to be really reliable or not? What do we think?
Really low.
Why?
Because it's very close to 1.
Okay, and what does 1 define?
1 is like perfect accuracy.
Okay, 1 is perfect accuracy. Okay, because 1 is 100%, just like Jameson's saying. So the closer we are to 1, the more accurate our model is going to be, just like Ben and Jameson are saying. Okay, so we have this exponential regression right here. Okay, are we done? What is the problem still asking us to do? Yeah, Ben.
Predict the number of likes that you will receive after 10 minutes.
Okay, predict the number of likes after 10 minutes. So what information does that give me?
Give you what your X value is.
Okay, so I have my X value and I need to plug that in. Right? Normally, you could use these and round and get like kind of a close answer. Lake in my last class showed me a very great method how to do this. Okay, so if you go to stat again and you hit calculate, and we're going to do this exponential regression again. Okay, you'll get this screen right here. We have our X and our Y list. Okay, we're going to zoom past those. This is going to say store regression EQ. Now I didn't make the calculator, I don't know what that really means, but I know that if I push alpha, so you're going to hit alpha trace. Okay, alpha trace. This is going to come up. My friend Lake in my last class told me this is going to store your value in your table, so your graph function in your table. So you're going to hit Y1, enter. Okay, so it's going to put it in the Y1 of your graph or your table. Okay, we're going to hit enter again and calculate. Okay, and we got the same thing. Now I can hit Y equals, and this function is going to show up there. Why does this help me now? Yeah, Justin.
We can graph it and then go to calc. Calc on the graph.
Okay, so we can graph it and we can see graphically where this is. What's another method we could use, Jameson?
We can use the table and enter 10 to the X value.
Jameson, you're exactly right. You're spot on. It's almost like you have a copy of my teaching lesson. Okay, so Jameson, we're going to do it his way. Second, we're going to hit table. And now we can just scroll down here. So like Ben said, our input of 10, and we have our answer. Okay, so you have this answer. Okay, so at X is 10, we have our Y, which is our output, which is that large number right there. Since this is a real life problem, our X and Y coordinates usually mean something in context. Can I get someone to describe what this means in context? Yeah, Ron, what do you think?
after 10 minutes, Beyonce received 206,353 likes.
Okay, perfect explanation. After 10 minutes, we have this many likes. Okay, and it's just gonna keep going on forever. Okay, so make sure that's written on your paper. After 10 minutes, just like Ronak said, we have this many likes. Okay, when you have this on your paper, let's flip over to the next page. Okay, thanks John for flipping, thanks Tyler. Okay, I almost have everyone on the next page. Yes, Justin.
I think it was mathematical and I got a different.
Okay, so Justin made a really important observation. Can you say that a little bit louder so everyone can hear us?
I did the mathematical way and I got a different answer.
Okay, so you did it the mathematical way and you got a different answer. What do you mean by that?
Like, I did 0.98 parentheses 3.48 to the 10th power, and I got 255,281.0134.
Okay. Ryan, are you gonna explain?
That's because on the calculator it didn't round to 0.98 and 3.48. It did the whole number decimal, so that's why you got a more specific answer.
Okay, Ryan, you're exactly right. Does that explanation make sense, Justin? Okay, so it's a rounding thing. Alright, we're on the next page. Okay, and we're pressed for time a little bit, so I'm just going to give you what these key points in our big idea is. Okay, I tried to write a little bit neater because I know you guys love my handwriting. Okay, this just says exponential regressions. You need this written on your paper, Cal. Exponential regressions are written in the form y equals a to the bx, and use the correlation coefficient r squared to determine predictability. Sadie, could you read the big idea for me?
We can use exponential regressions to model real-life data.
Perfect. Once you have both of these things, let's flip over to the next page. Okay, thank you for those that are copying this. And guys, exponential regressions and r squared are actually really important. So when I used to do financial analysis, right, we would use financial models and we would use r squared to determine how viable that model is. Okay, so how good of a predictability that model is. So these are really important, and that's what we're going to be talking about today, is how we can use exponential regressions in the context of real life problems. Okay, thanks Nora for flipping. Thanks John for flipping. Thanks Lauren. Okay, and if you're on the next page, start to think about how we're going to solve that problem. Okay, so almost everyone is there. I'm going to give you guys 30 seconds. Start to read and annotate this problem for any key details, and then I'm going to cold call someone to help me get started. Okay, 30 seconds starts now. Okay, so try to pick out what's important. What do we know about this function? All right, 2, 1, and I should be up here. Thanks Lauren, thanks Jude, and thanks Rebecca. All right, so we are on our next page. Let me just flip over. Okay, we're on this page. And those of you that didn't follow directions and started calculating this are going to be upset because I'm going to change these numbers. Okay, these numbers should be 146.7, 135.1, and 126.2. Okay, so if you started to cheat a little bit, I'm sorry, I changed the numbers. What do we know about this problem? What do we know about this problem? Ben, what do you think? Ben, Ben. Sorry.
We know that the x value is time in minutes and that the y value is temperature and Fahrenheit.
Okay, so we have our x and our y values, and you set them perfectly in context. Thank you for that. What else do we know? Jameson, what do you think?
We can also see that this equation is negative as x is increasing y.
Okay, I really like that. So you're saying as x is increasing, y decreases. Ronak, what else?
Near A value.
Okay, what do you mean I know my A value?
Because like, you're given your y-intercept, this is once again actually 5, so that's really fun.
Okay, so I know my A value. But Rana, what, if I know an A value, what are you assuming about this function?
Wait, what do you mean?
So you said at 0, we have our A value. What did you just assume about that function?
It's a y-intercept.
For what, Lauren?
Exponential function.
Okay, so you assume that it's an exponential function, just like Lauren said. Can we assume that this is an exponential function?
No.
No. Okay, it looks like it could be, but how can we prove this using what we just learned about our big idea and our key points? Ryan?
You could see that you found the rate of change of two different ranges.
Yeah, so let's build on that a little bit more. So we can find our rate of change. How can I use what we just talked about on the first page to find my rate of change, to compare if it's linear or exponential? Okay, what do you think? What do you think, Selena?
Maybe we can graph it on our calculator.
Can you speak a little bit louder? I know you're sick.
Maybe we can graph it on our calculator.
Okay, we can graph it on our calculator. You're getting there. We're going to use the calculator, but what did we just talk about? What did we just do on the first page, John? Yes, John.
Oh, the calculator, all that stuff.
Yeah, what was that called?
Exponential regression.
Okay, so we can use an exponential regression, and I can compare that to what other type of regression, Lauren? Okay, that's exactly what we're going to do. So Lauren's spot on. We're going to determine, is this linear or is this exponential? Okay, and in order to do that, we need to input these values into our calculator. Okay, so we're going to start all over, and we're going to edit this. Okay, I want you to work with the person sitting next to you. Okay, you can calculate if this is going to be a linear or an exponential regression. Okay, linear regression is 8 for some of you, and exponential regression is 0. Tell me which one you think it is and why. Okay, work with the person next to you. I'm going to give you 1 minute. Try to use your partner for support. Okay, 1 minute starts now. Plug in everything. Oh, sorry.
That's pretty good.
Hey, you guys have about 15 seconds left.
It's like, it doesn't feel bad, but yeah.
You can't justify it.
Yeah,
I think it's cubic.
perfect. Exactly.
Alright, eyes back up here. 3, 2, and 1. Thanks, John, for your eyes. Thanks, back table, for your eyes. And thanks, Edgar, for your eyes. Alright, when you calculated this, okay, what did you get, Ben A, for your R values?
For the linear regression, the R value, the R squared value, right?
Yes.
The R squared value was 0.996, but for the exponential it was 0.98.
Okay, so Ben's exactly right. I'm just copying down what he said. So he said linear R squared is 0.96, and our exponential is 0.98. Why are we looking at our r squared terms, Rebecca?
To find out how accurate they are.
Can you say that a little bit louder?
To find out how accurate they are.
Yeah, you're exactly right, to figure out how accurate we are. Max, do you want to build on that?
We tried the cubic regression and that had a r squared of 1.
Okay. For this one, we're only going to do linear and exponential, but I really like how you're thinking about other stuff. Great job. Okay, so we have linear and exponential. We compare the r squared. Which one do you think we should use, Harrison?
Probably the exponential,
Why do you say that?
because it's more accurate.
What makes you come to that conclusion? Okay, it's closer to 1. Okay, Harrison's exactly right. We're going to use our exponential function here. Okay, oh, sorry, we're going to use our exponential function. And we have other key details from our calculator. What else did we find out using the exponential regression? Okay, what else do we know? Jude.
Let me get there.
Take your time. Thanks, Jude.
We know the A and B values, right?
Okay, we know our A and B values, and can you give me those? What were those again?
They were, A was 180.94.
I think it was a little bit lower.
A little bit lower.
176.63.
Okay, 176.63. Let's go 2/8. Okay, and Ben, you got the B value?
B value was 0.9682.
Okay, 27. Okay, we have our A and B value. Now what can I do, May? Okay, we can plug it into our equation, which we have right here. So we can plug it into our exponential equation. Okay, and when we do that, we get t of x equals, help me write this, Johnson.
T of x equals 176.63 to 8 times 0.9627 power x.
Okay, 0.96827
Power x.
x. Okay, so we solved that problem. Okay, we solved this problem. Now I want to think about our next problem. Okay, I want to think about our next problem. Alai, can you read B for me?
I can read it.
Hank?
If the ambient temperature of the room is 70 degrees Fahrenheit, check the temperature of the cup of coffee after 1 hour. Show your work to justify temperature.
Thanks a lot. Okay, so we have this new information, and I want to think about a cup of coffee. Okay, we know based on this model what's happening to our cup of coffee. What's happening? Okay, Elijah, what'd you say? It's cooling. Okay, our cup of coffee is getting colder and colder. Is that going to continue forever?